So, the problem that we're really working on here is kind of an intersection. So, living here in the desert with our seasons, our water managers really deal with the paradox of having both too little water and too much water as we fluctuate between seasons of drought and flooding every single year. In addition to that, we live in a city which presents its own unique issues. This here is a pretty typical transect of like an urbanized area and an undeveloped area, and then kind of what happens in between. The takeaway message is that as we urbanize an environment to create a city, we pave over our surfaces with asphalt and concrete to create our roads, our rooftops, our parking lots, all the things that make city life a little bit easier. In the process, we disconnect water that reaches the ground surface from infiltrating into the soil below the way it would before the city was constructed. This creates a number of changes and issues with the way water moves through our urban environments, and they're typically captured in the term urban stream syndrome. So this diagram is a pretty typical suite of urban stream syndrome impairments. So as we pave over our ground surfaces, as we channelize our rivers and our streams, and as we bring in water from other areas that we put into the environment, we change the environment. This can come in adverse impacts or impairments in terms of flow, where we see increased flooding. We also see degraded water quality and degraded ecological habitats. So this is what it can look like in Tucson. We have a lot of concrete here in our city, and when it rains, it's very easy for it to flood. This can create a lot of issues, especially for people and drivers who might get stranded or end up in flooding conditions. So this is a common issue for cities worldwide. This is not unique to Tucson, but we do also experience it. So there's been a number of solutions that people have been coming up with in cities all over the world. A lot of them deal with capturing rainwater as it falls or as it runs through the streets as stormwater. There are a number of techniques, and they're collectively captured in the term green infrastructure. Green infrastructure is a really broad term, similar to rainwater harvesting and low-impact development. These are all things that kind of circulate in the same field. For today's talk, I'm just going to use the term green infrastructure, just to keep it simple. And as I'm talking about solutions, I'm really going to be focusing on the ones that capture stormwater as it's running through the street. So here are a couple of cartoon schematics of what that can look like here in Tucson. These are both from local advocates, Brad Lancaster and Watershed Management Group, who are both doing a lot of work to increase adoption locally. So in general, the idea is as water flows through the streets, to capture some of it to water pockets of earth. And these pockets of earth can come in all different forms. They range in names from infiltration basins to bioswales, bioretention basins, chicanes. The list goes on, but they generally have the same purpose, which is to capture water, infiltrate it into the soil, hopefully support some local plant life, particularly trees whose shade can provide a lot of benefits when it comes to reducing heat here, especially in the summertime. And also, by capturing stormwater, we can offset water use, potable water use to irrigate outdoor plants, which can also lower your water bill and help conserve our municipal water supplies. So while this is a schematic where water comes and enters or enters a series, here are some pictures of what that looks like in Tucson. So you can see some basins that have been put in to capture stormwater that are still supporting the plants after the stormwater recedes, which can help result in some nice, big, beautiful canopies locally. So these are just some examples of what it looks like in Tucson, but there's a really big variety. And so, as I mentioned, I'm a hydrologist. And so before I dive into the specific research that we're doing, I wanted to take a moment to introduce the kinds of tools and perspectives that hydrologists use when tackling a problem. So, can anyone here, especially who's not a hydrologist, I saw some in the audience, can anyone tell me what a watershed is? So we heard it's the land, it's the area that funnels water down to a point. And that is what a watershed is, and that's what we look at in hydrology. So this diagram is kind of a schematic of a typical watershed diagram. Watersheds can be very large, like the Mississippi River watershed, which drains a large portion of the eastern half of our country. It can also be as small as your yard. What's really important is that if you're looking at a point, it's all the area that's going to drain water down to that point. And so that's the unit that we look at as hydrologists, and that's what helps us delineate or draw boundaries on the areas that we're interested in. And so once we have that delineated, what we like to look at is the water coming in and out of that area. So this is just a cartoon drawing of what a water balance can look like in a similar area to ours in New Mexico. So as I mentioned, we're looking at water draining down to a point. So as hydrologists, we can install equipment that helps us understand how much water is moving through that point. And through that, we'll understand how water is moving. So if we can just take a quick moment, perhaps close your eyes, use your imagination to just think of a dry city street in the summertime. And then if you think about a rainstorm happening, you have the rain. Shortly after, you see some water coming down the street. Perhaps it's just a little bit at first, but then it builds. Maybe you get your feet wet, maybe your socks get wet, maybe the sidewalk floods, but it'll rise, and at some point it'll peak before it comes back down to dry conditions. So that is what we try to graphically depict with a hydrograph, which is this schematic over here. So we see that it rains, and then the flow rises, it'll peak at some point and come back down. So for us, we'll look at these, and these hydrographs can tell us about what's going on in a watershed, and they can look very different from place to place. So here's a quick example of what watersheds can look like in other environments. Our hydrographs tend to fall like the ones on the right side, whereas places such as the eastern United States will have hydrographs more like this, where you have a smaller peak, it comes a little bit later, and the flow will last a little bit longer. Here, we tend to get a lot of water fast, so we see a lot of flash floods in this region. And so this is, the hydrograph on the right is kind of what we would call a flashy hydrograph. So now that we've covered some of the basic tools that we're looking at, now I'm going to get into how we're applying this and how we're looking at green infrastructure here in Tucson. So here's just a road diagram, a schematic. And so as green infrastructure gets implemented in a city, it might get implemented kind of randomly by homeowners, by neighborhood associations, by the city, because a lot of times when we put in our basins or this green infrastructure, we're really looking at what space is available, what people are interested in putting it out there, and where are the homes located, where the homeowners want to put it in. So what we're interested in as hydrologists is, despite this kind of random spatial implementation, how does it cumulatively influence the watershed scale? How does it function as a network? And so we can have basins that look all different ways that are designed differently, that perhaps function differently, that receive water differently, or that may or may not get clogged. And what we're interested in is how do they combine? How does that effort combine? So we're really not looking at the individual scale, but we're looking at the cumulative effect. And so going back to our hydrographs, this is just kind of a cartoon to show a developed watershed and what the hydrograph might have looked like before it got urbanized. So as we can see in our urban areas, we see more water for longer that comes up faster. So what we're interested in is, where does green infrastructure fit in? Our hypothesis for this study is that we think it falls somewhere in the middle, where it won't take us back to pre-development conditions, it won't take our hydrology back to before the city came, but that it might help reduce a little bit of the problems that we see due to the city. So this is our, like I said, our hypothesis for the study. And so now we're going to go into how do we actually do our research. So for us, I'm part of a broader research group, so now I'm going to get into more of my specific research, where I'm collecting data, real-world data, from an environment. I'm not manipulating anything, not changing anything, we're just observing what's happening, and we're using a paired watershed approach. So what that means is that we're using two different watersheds to help us understand what's going on in between, or to isolate the impact. So we have two paired watersheds. This is one and this is another. For both of them, flow goes this way. So we have an upstream area in the crosshatched area, and then we have a downstream outlet. And in between the upstream and the downstream are neighborhoods that have implemented a good amount of green infrastructure due to efforts of homeowners and neighborhood associations, and in some cases the city. And so what we're doing out here is we're collecting data in the form of flow data and in the form of water samples. Our equipment, when it's out in the field, kind of looks like this. It's just this nondescript metal conduit to protect it from the elements that has some arms that'll extend out into the channel to measure the flow and to collect water samples. This is what's actually located within that metal casing. This is called an autosampler, and I often describe it as R2-D2's analog grandfather, because it beeps and all that stuff, but not very smartly. And inside the autosampler, there's also a ring of bottles that'll fill automatically as flow moves through the wash. And this really helps us in terms of safety, so that we don't have people during these flooding events trying to collect water samples. And then this final picture is just kind of an example of what one of our study sites might look like when there's flow. And so here's what some of our real-world data can look like. These are hydrographs that we've collected from our paired sites. As you can see, they do kind of have that flashy nature, and there's two of them because we're looking at the upstream and the downstream site. The upstream site is the smaller one, and then the downstream site has the larger hydrograph because it's draining a larger area. And this is a pretty common thing that we see. So we take this data that we're collecting and we look at it in terms of statistical analyses, where we try to look at the type of data we're collecting, the distribution of it, to help us understand what kind of analyses are appropriate for the data that we're collecting. And from that, we'll compile it, we'll compare it, and that allows us to look at different sites and see how they compare. So, while we're still in the process of doing the data analysis, so in terms of what exactly is happening, I'm not prepared to say right now in terms of concrete results, but there's one thing that we have seen become pretty obvious in our research, and that's implementation is key. I know this sounds perhaps obvious or simplistic, but it really can't be overstated. Because when we're thinking about individual basin implementation, or we're thinking about it along the street in a neighborhood, what we found is incredibly important if we actually want to have an effect on the watershed scale is that there is implementation throughout the watershed, and that what is implemented functions well, and that it does collect water when it does rain. And so it's not just the amount of green infrastructure you have installed, it's how it's designed, how it's functioned, how it's maintained. And so a lot of this actually takes us out of the hydrologic realm. And this is where social scientists and policy and city officials come in, where in order to really have a strong watershed effect, we really need to get more basins in the ground collecting stormwater. And to help, and through all that, we also increase shade, we increase canopy, and general livability in the region. So to recap, we're interested in how water is moving through our landscape. And we're thinking about how all of this combines, how the features of the watershed, green infrastructure, or rainfall events all combine, and how they all fit together to help us understand how to implement green infrastructure, how to design it in order to maximize our benefits. So thank you. I wanted to give a quick acknowledgement to all of these organizations that have helped support this work over the years. Tonight's programming, as you've heard, was brought to you by the College of Science, and particularly for me, the Carson Scholars Program. And this work is also supported by the National Science Foundation and the Urban Water Innovation Network, and now the Babbitt Center for Land and Water Policy in Phoenix. I am happy to take any questions now.
Woo!
We have a few questions. We'll go with you, and then
I'm curious about what resources there are so we can learn how to create basins in our yard.
oh, that's a good question.
Would you repeat that?
So she's interested in resources available to help create basins in your yards. And so some of the figures that I showed earlier, one of them was from Watershed Management Group. That's one of their large missions, and I have seen people from WMG here tonight. In addition, there's a number of organizations and individuals working in Tucson to help increase implementation. I can talk to you about that afterwards as well.
Have you attempted to estimate how much water we could capture with an extensive network of
So the question was, have we tried to estimate how much water we could capture with an extensive network? And the answer to that is a study partner has done that. So as I mentioned, I'm more on the monitoring side, but I'm also working with a PhD student who just finished, who was working on modeling these watersheds so that he could tinker with implementation levels. And he did see a really strong increase in effects as we added more and more throughout the neighborhood. And I can talk to you about that afterwards, can get you the name. And right there.
This is focused on Tucson, and it's really essential for us. Have you looked at what's going on in other desert similar cities, and if there are systems that we could learn about from them?
So the question was, this is a very specific to Tucson study. Have we been looking at other cities and other desert cities and how we can learn from them? And so, yeah, there's been a number of cities that have also been working on this. LA, Los Angeles has been a big one, and there's also been cities in New Mexico who have undertaken this, Phoenix, and cities in Utah as well. And so we're all doing kind of different kinds of studies and tinkering with different things, but collectively, when you put it together, there is a picture that emerges, and a lot of it kind of comes down to design, to maintenance, to placement. It really depends on the specific questions that we're asking to allow us to compare. So I'll take you, and then you, and then I'll go to you.
So are there any projections for long-term water forecast for this area for over the next 20, 30 years?
So projections for long-term water forecast for the next 20, 30 years. In terms of,
More of it or less?
are we gonna have more or less? I see some people in the audience that might be able to answer that, but I think that's a little outside of what I would be qualified to comment on. And do you have a question? Oh.
Yes. So in your study areas, like your graphics showed a lot of curb cuts. Do you know what the percentage or the breakdown is between the systems in your areas, between curb cuts and then just other systems that are harvesting off of other surface areas besides the road?
That's a good question. So the study partner did look at various forms for us, since we're really looking at stormwater that flows through streets and makes it into the washes. The curb cuts are really the relevant features that'll influence that the most. In terms of things that are implemented on more of a household scale, like cisterns, just the volume that they capture and the fact that they can fill up pretty quickly. We don't think that that's a large enough volume to really influence the larger volumes that are moving through the streets. But that's part of the other study that I was mentioning, done by our partner. His name is Yoga Korgaukar. He did bring those types of things into his research and looked at how to also bring in like rooftop harvesting. And I saw you.
Maybe related, what distinguishes a good implementation from a less than good implementation?
So what distinguishes a good implementation from a less good implementation? In terms of, I can answer this more anecdotally in terms of what we've seen. And overall, we see these basins during the dry periods for the most part, but when you're actually walking around when it rains, you'll see that sometimes inlets are blocked so that the basins aren't even receiving water. So I would say that's a pretty big thing, is just, first of all, is water coming in. Other things that you can look at are infiltration rates, how fast water is soaking into the soil. And we did have some master's students in our department that looked at that more on an individual basin scale. So those are a few of the first cut easy ways to look at that. And then once you kind of answered those, you can kind of go a little bit deeper. And then go you, and back. Did I see other hands too? So go you, and then I'll get back to you after.
One thing I see when I see this, do basin designers worry about outflow? Do the basin designers worry about outflow? Because you don't want the water standing for too long, because mosquitoes.
So the question/comment was that basin designers are also interested in how fast the water goes down, that we don't want standing water, we don't want mosquitoes. And that's where knowing your basin maintenance and follow-up after the basin has been installed becomes important. And that's where some of the things like you're asking about, how do we know if it's working well, the infiltration rates, how fast it's going down. And you don't even have to, monitor it second by second. If you have a basin and you see that it still has water a day or two afterwards, which we haven't really seen yet, even in some fine-grained ones, but those are the kinds of things that you would be looking at to help increase that. Do you have a question?
Does U of A have an Institute for Sustainable Practice?
Does U of A have an Institute for Sustainable Practice? Yes, I believe we do, but I am not the person to answer that.
I've never done that, but very quickly, the Institute of the Environment has been reconfigured, and we're undergoing. I'm affiliated faculty with the Institute of the Environment, and we now have a new name, which is Arizona Institute for Resilient Environments and Societies, or ARIES, and a new interim director. Yeah, mouthful. So stay tuned is all I can say at this point. But we welcome comments. So
Are you familiar with David Lipscomb University's program?
No, I'm not, but please come talk to me afterwards.
And then I'll go to you afterwards.
So if a person wanted to have a cistern
where would you start? Tucson Water? Where do you get those? Where do you?
So if a person wants to have a cistern, where do you start? I did see somebody from Watershed Management Group here. That find Madeline over here afterwards, and she will fill you in.
I got more.
I'm gonna get this question back there really quick.
So, how many monitoring locations do you currently have? How did you choose the locations? And are you looking for new locations?
So the question was, how many locations do we currently have? How did we select them? And are we looking for new locations? So currently we have, for this specific project, we have 2 paired watersheds, meaning we have 4 watersheds for this specific study. The way they were chosen was going back to, so let's focus on this figure. So we have a monitoring point here, 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 and here. What we were really interested in for this was finding an area where the upstream did not have that much green infrastructure installed and where the downstream did, so that we could isolate those effects, which is actually easier said than done when you're dealing with the chaos of the real world. Are we looking for new locations? As far as we've been monitoring, we started planning this and putting in the equipment in 2016. We've been monitoring these for a number of years, so I'm on my way out with my PhD, but my advisor could certainly implement more. And he just walked out the door when I said that.
Boundaries of that northern watershed.
Say that one more time.
What are the boundaries of the northern watershed, the red watershed?
So the boundaries, this is a pretty small one. So we're looking at, this is Euclid or 1st Street right here. And this is 6th Street right here. And this is,
Avenue.
which one?
6th Avenue.
This is 6th. Okay, this is 6th and that's Speedway.
Speedway.
It's a little north.
And it goes.
It ends at around the top of Mansfield.
So that yellow stack is for the boundary.
Yeah, exactly. That's 4th Avenue.
Did I see any more? Oh, I'll go to you and then back to you.
Here is a homeowner's group. For those of you who know the story, we're all sitting here, we can't remember the name, but they're down off of Oracle, there's a neighborhood, and they've got grants. And the president is great with mentors and showing how various people have done.
Okay. And then
I'm just wondering if there are any local, or statewide, or national incentives to implement these in our neighborhoods. And last, having,
so there's 2 questions. Are there local, state, or national incentives to put these in? And how did I get interested in this field? So in terms of local incentives, there are Tucson Water has a water harvesting rebate, and then also at the same time, right now the city is embarking on a green stormwater infrastructure fund or fee that'll it's going to increase our water bills slightly to be able to pull a fund where departments can work together to implement these things and have a workforce that can also help make sure that they're functioning properly and maintain them. Plan, implement, maintain. So that's more on the horizon, but we do have the water harvesting rebate. And then there are some people here in local government, like Mead over here, who can also help fill in on anything, and perhaps if you want to connect afterwards. In terms of how did I get interested in this field, like I said, I was working in contaminated soil and groundwater issues before I came here for my PhD. And so working on those, you're really working on individual properties. And, yeah, oh, is it louder? And,
younger, how did you get into
Oh, when I got interested in water. Oh, wow. How did I get interested in science and water? We are going back like over a decade.
Was it Captain Planet?
It was not Captain Planet. Still, I'm not very familiar with Captain Planet. But you know, when I was really in my undergrad and deciding what kinds of things were important and what did I want to work on, I fluctuated in a lot of different fields, but ended up thinking that water is the least abstract thing. Every single field, everything that we have is built on the availability of water, so that's what I wanted to work on. So I think I'll meet with people I'll speak with people one-on-one from here to kind of wrap up the Q&A session, but I'll be around for a little bit if you want to come up with questions, and there's also a lot of experts in the audience too, so if you want to turn around, meet your neighbor, feel free. So thank you guys so much for your time and attention tonight.